Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is another in my practice session series for the Red Hat Certified Specialist in Managing Automation with Ansible Automation Platform Exam EX467. Before I dive in, I want to thank returning subscribers for watching another video, as well as invite anyone who's watching, if you haven't subscribed yet, to click the subscribe button. Also, just a reminder that these are my practice sessions where I'm going through all of the posted objectives by Red Hat and either demonstrating the objective or explaining whatever the concept is behind the objective. And at the end of the video, I'll do a little self-assessment, and hopefully I will feel confident about the objective to be able to do exam tasks. And if not, I still have just a couple of days left before my exam. Obviously, at this point of preparation, there's not going to be learning anything new, but if I need to try to brush up on something to get it in the front side of my head, so to speak, I have a couple of days left to do that. That being said, these should not be considered tutorials, nor should they be considered training sessions or authoritative information. I do try to have the information accurate because hopefully at this point in preparation I haven't learned stuff wrong, but I am learning right along with you. I put these out on the internet in hopes of those that are preparing for this exam might see some of the stuff that I do to practice and give themselves or inspire some ideas of their own to do for their own preparation. But that being said, these should not be considered official tutorials by any means. So I'm moving into the install and configure automation mesh part of the objectives, and I believe I should be able to touch on all of these in a single video. If it gets too long, I might split it into two, but I think I can get it in one. And we're going to be installing the automation mesh, working with instance groups, and trying to run job templates only against a specific instance group. So just explaining kind of what automation mesh is, this is kind of the scalability aspect of Ansible Automation Platform. So far, the environment that I've worked with, I've had my single automation controller, a single private automation hub, which you don't necessarily even have to have a private automation hub, and I've had a couple of nodes that are the nodes that I would be configuring with the controller. What you can do is have multiple controllers, and if you want, you can have multiple private automation hubs. You can also separate the function of a controller, which is storing all your job templates and managing user permissions and all of that aspect. You can separate that from the actual execution. You can have servers that are their sole job is to execute the things that the controller tells them to. This can be particularly useful if you have multiple data centers that have different geographic locations, and it would be much more performant for execution nodes in that geographic location to execute the stuff that automation controller tells it to, versus you having to do that all over a WAN. And the way automation mesh works is basically, it's not its own network as far as it's going to have its own network address space and such, but it's basically a little mesh network that all of these pieces communicate to each other on. Most of that communication is over SSH. There is some that is over, I can't remember the port off the top of my head, but when you get into looking at peering and such, there's another port where that communication happens, but between the control nodes themselves to keep themselves in sync and the like. There's another piece, and that is having a hop node, let's say that you're in an environment where you have like execution nodes in a subnet. That subnet can't talk directly to the controller. You would have a hop node that single node can talk back to a controller, maybe on your management subnet. And then through the hop node, information gets out to the execution nodes to run the various actual Python scripts, which your playbooks and such are. So to install automation mesh, you're going to basically do the same procedure that you would for installing the automation controller and the other components. Let me go to my downloads folder. I'm actually going to copy my inventory to inventory.back, and then we'll do some editing here. Okay, so I'm not going to be able to do a whole lot because I don't have a ton of VMs to work with, but we'll be able to make do with a couple of things here. So right now we have a single automation controller. You have to have an automation controller, like at least one, but we will add another, and I think I named it Lab Controller 2. So now one thing to note, you can see here in the comments, you can specify node type. Your control nodes can be of two types, either a pure control node or a hybrid node. A hybrid node is a control node that does both control node things, which is storing your job templates, and or say store really that's happening in a database, but you get the idea behind that. Or it is a hybrid node where it can do the control node stuff as well as execute against your managed nodes, whatever your job templates and such are. So if I wanted to do a little test here, let's see if I can have one of both. Do node type control. We'll allow this one to be a hybrid. I think by default, these are hybrids. This peers thing, so peering is really kind of the special sauce of the automation mesh. Right now, there will be a peer connection, or rather, all of the automation controllers will try to peer with any of the controllers that are within the execution nodes inventory group. You may or may not want this to happen. You might have automation controllers in two different data centers, and you would have a separate set of peers for that. Or in the example that I gave before, you might have a hop node that is used to make that peering connection come back to your automation controller. So I'm actually going to get rid of this. Oops. I'm not going to explicitly say any peering here. One thing with peering, the peering is two-way communication, but I think sometimes it's helpful, or at least when I've been practicing writing some inventory files and such for automation mesh, I think it's helpful to think of peering as going backwards. Like the idea of the peer is this is its way back to getting to an automation controller. All right, so for execution nodes, here's what we're going to do. I'm going to have lab node 1, internal, and lab node 2 actually be execution nodes. By default, these will be execution nodes. I guess I could do execution nodes vars and do node type there, but I want to explicitly call them execution nodes. All right. I'm going to keep the rest of this the same. One thing to note, these variables here like web server SSL cert, since I'm using my certificate that's everything, I'm not changing this, but you could, instead of specifying this within the all variables section that we're in right now, you could specify this as inventory variables earlier in the inventory. This is what I was looking for before. The receptor service is part of that peering communication, and if you want, you can configure whatever port you would like for that, and your default is the 27199. All right, all that looks good, so we'll save that. And I currently have, my environment, so let's see what happens when we run setup now that we've made some changes to the inventory. So we'll do our setup.sh. We are going to do become, so make sure it's root, and we are going to do ignore pre-flight errors equals true. And let's see what happens. Though it should not take as long, it will take a non-trivial amount of time to run for setting up the other nodes. So I'm going to pause the video and then come back once it is complete. Yay, practice sessions and catching errors. So I'm sure some of you that are well-versed with automation mesh realize the error that I made. And since I removed that peering, then I have basically broken the mesh, because the execution nodes don't have a way of getting back to the control plane, which is where your controllers are. Which actually, that reminds me of one other thing we can do. So let me go back into the inventory, and I'll go ahead and configure peers here. So exactly as it is. The thing that I did, I forgot, before you run this, you actually can get a visualization of what your topology is going to end up being. And you can do that by creating what's called a little dot file, and that can be converted to an image file. And there's a package that you can get for this. I think it's called GraphViz. Let me see if I can install that. I think it's GraphViz. We'll find out. Yep, GraphViz. And then what we can do is run the setup script. I may or may not need to do the ignore pre-flight errors with this, but I'm going to anyway. And with the tags, I think it's generate.file is the name of the tags, not tage. Tags. Let's see if this does what I think it will. Okay, so it looks like it did. And notice we now have, well, I was expecting to see something here. Maybe that was the wrong tag. I expected there to be a dot file. Oh, that didn't do us much good, did it? Yeah, so that did not do what I thought. Let's do, since this is basically a playbook, let's see what happens when I do this. When in doubt, list tags, right? And actually, I'll do one better. I'll grep boo. All right, so grep failed me. Is it not showing all the tags that I wanted? That's something I'm definitely going to have to look up again. Let's see if help will actually help us here. And this is just showing us the normal stuff that comes with the playbook. And list all available tags. But of course, that did not help. I want to think, I thought it was generate.file. So let me think. Let's say I'm on the exam and I can't remember this tag. How could I find it? No, that's not one. I didn't mean to actually exit my terminal. No, there's an easier way to do this. Or so I thought. This course is giving me all the stuff that's in like the roles and collections. All right, let's do this. Let's take a look at the actual script itself real quick. I really thought it was generate.file was the tag that I needed to pass. A little disappointed that generate tags did not give me what I want. Now, of course, I could probably go to the Ansible doc site and find it quick, but I try to operate on the assumption that I will not have any type of internet access, because typically you do not. And that's the help message. Okay, so there's a variable called playbook that has been established somewhere. So let's do grep playbook setup.sh. Okay, so that's going to be collections, Ansible, automation platform installer. Okay, so I wonder if I'll be able to get that from here. And of course, it's going to do a syntax check. So let me just less it instead of trying to get list tags. Or I can do this. Okay, so it's underscore generate.file. Or it's generate.files, but with underscores. All right, so that might be something I try to commit to memory. But there you have it. Try to find it without using the internet. So let's try this again. Setup.sh. I'm going to try it without the ignore pre-flight errors. Tags. Generate.file. Now this does not take nearly as long because it's not actually running the thing. There's our mesh topology dot. Okay, so now the dot command, you're going to have dash T. Is it dash lowercase t or uppercase T? Let's take a look. Uppercase T. All right, so we'll have dot dash T, and we're just going to say JPEG, and we want the output file to be topology.jpg. And so what this is going to do, if it worked, which I'm confident that it did, we'll have a topology.jpg file, and that shows what our mesh is going to look like. So we have both lab nodes that are able to reach back to both of the controllers, and there you go. So before you take the time to run through, making your mesh, you can do that there. Let me do, actually before we install this, let me make another change in the inventory. I can show you how a hop might look. So we're going to add some, of course these aren't actually going to exist. This is just for an example, but let's say lab node 3. We're going to call it an execution node. Lab node 4 is going to be node type. It's going to be a hop node. I think you can use, as the comments are talking about, like the names execution, and what I'm actually going to do here is set the peer. Make sure I have that right. Automation controller. You'll see why I'm doing this in just a moment. This peer will be automation controller. This peer is actually going to be lab node 4, and this peer will be that group. And I'm going to remove the execution nodes peers, and let's do our little topology again just to see what would happen. Lab node 3 does not have a path back to the control plane. It should. And obviously, this runs checks to make sure that you're not going to have a broken topology, but let's see. Oh, even though it is a singular peer, peers plural is going to be the variable. Okay, so there's our dot file. We'll do dot JPEG again. And let's have a look at our mesh this time, see what the end result's going to be. Okay, so we have lab node 4, remember, is a hop node, so it's going to have a connection back to both of the automation controllers, as do these two execution nodes. And lab node 3, its way back to the control plane is through the hop. That would be lab node 4. So that's an example of what's going on with that. So now what I want to do, because we're actually going to run the installation this time, is remove those. We actually can keep the peers the same because we've defined it there. All right, this should work. So now we'll actually run the setup. And famous last words in IT, this should work, and it'll take a bit to do. So again, I'll pause the video and come back once it's completed or once I get another error. All right, so we've made it to the end with no errors. Let's see what the end result is. So we can go into our controller. Actually do that with another tab. First error does not give me much confidence. So we'll see what happens. Okay, so that all this looks normal. We can go to topology view, and this, I can zoom in. Yeah. And this is kind of what we expected. We have our control plane that directly has communication to our execution nodes. We have the hybrid node, which is lab controller 2, because remember we gave it both it is just a controller as well as it can be an execution node. And so all of this looks right. There are some health checks you can do. Let's see if I can find that. It may be more of an instance group thing. Well, yeah. Well, some instance groups are already created. What the instance groups are is basically like logical groupings of stuff. And that, since this video is getting long, I think I'll hit instance group stuff in a different video. But we should. Thought there was a way of doing some health checks with this. That might be something that we have to look at. And let's try to log into lab controller 2. because this should have basically the same stuff as Lab Controller 1 because it's a part of the mesh. Yep, and it has all of the stuff, and this talking to the same database server as Lab Controller, thus, why it's going to have all of the same information. You can also expand this. You have load balancers in front of stuff, but that's outside of the scope for the exam. So I think for this video, since we are getting a bit long, we've installed Automation Mesh. I've talked about conceptually what's going on with Automation Mesh. I'm going to consider that a pass. I might want to try to refresh some about the receptor service and the ports to be more aware of them. And other than that, I think I have a good basic understanding for what the Automation Mesh is and the procedure for installing it. So if you found this video useful, make sure you do click like and feel free to share it with others. I want to thank returning subscribers for watching another video. And also, if you have not subscribed yet, make sure you do click that subscribe button and ring the bell so you know when new content comes available. Thank you for your time, and I will see you the next time.